Welcome back. Today we are going to learn how to find the area of some different polygons. And remember, a polygon is just a shape with many sides. It's a closed figure. And we're going to specifically look at triangles, parallelograms, trapezoids. And this is a very basic lesson. We'll go over what the formulas are, and then we'll just do some practice problems where we can plug in those values and find the area, and we'll just do a few word problems. But be sure to subscribe so that you get those notifications for future lessons, because some more upcoming lessons I have planned will really talk about how do we get these formulas? Let's make sense of them. Why are we doing 1/2 of the base? And we can really look at, we don't want to just know how it works, but why it works. And so today, like I said, is just going to be a basic understanding. We're going to look at those formulas and plug in those values and find some solutions. So let's go ahead and get started. We're going to start with reviewing how to find the area of a parallelogram, and this excerpt here is straight from your workbook. If you would like a copy of your own, check out a link in the description. So a parallelogram is the way we find the area is the base times the height. Now remember, area is giving us 2 dimensions, and when we think of it in a real world context, it's like if I'm painting a wall or I'm laying down grass, it covers everything that's within that space. It's 2-dimensional. And so for the area of a parallelogram, we're going to do the base times the height, and the height is represented by that dashed line. It's not the parallel line that's slanted. Okay, we want to use the height or the units that we see measured for the height of the parallelogram. And technically a rectangle is a parallelogram, and it's the height is already very clear for us to see because we have that 90-degree angle. So when we look at this example here, we have the area equals 5 times 4. And so one of those sides of the rectangle would be 5, the other would be 4, and then we're just simply going to plug in the base and the height and multiply. Because it's a 2-dimensional shape, our units are squared. So it would be centimeters squared or units squared, whether you're using feet, whatever the units are, you include the exponent 2 to indicate and show that we're solving for area, squared units. Now let's look at our next one, a triangle. A triangle is next, and so the area, the formula that we use for the area of a triangle is 1/2 times the base times the height. And so we look at this example here, the triangle, if the base is 5 centimeters and our height is 3 centimeters. So we can plug in those values, base times height times 1/2. Now remember that all fractions are division problems, so multiplying by 1/2 is really the same as dividing by 2. When we multiply, we can multiply in whatever order that we want. And so if I do the base times the height, I get 15. And then if I'm multiplying it times the numerator of the fraction 1, it stays as 15, and then I divide by 2. So 1/2 of 15 gives us 7.5. So for this example, the area would be 7.5 units squared, whether it's centimeters. Yeah, it says here it's centimeters. So we'd say centimeters squared because we're talking about a 2-dimensional shape. Lastly, we have the formula for the area of a trapezoid, and a trapezoid is 1/2 times base₁ plus base₂ times the height. So a couple things here. First, base₁ can be your top line, or as you can see in this second example, it's labeled with an A. So you can do B1 or A, and B, it's basically the top and the bottom of your trapezoid. So you're going to add those 2 measurements first because it's in parentheses. And so you can reference back our introduction to the order of operations to help you remember the order in which we do our operations. That's linked in the description. You can check out that video. So area equals 1/2 times base₁ plus base₂ times the height. So if our first base is 8 centimeters or A, and our second is 6 centimeters, we are going to add 8 plus 6 gives us 14. And then remember, you can multiply in whatever order you want. So once we have that number, we're multiplying 1/2 times 14 times 5. And so if you want, you can do a 1/2 first, and 1/2 of 14 gives you 7. And so then we do 7 times 5 gives us 35. So the area for this trapezoid would be 35 units squared or centimeters squared. Let's get into some practice problems and do some more work with area with polygons. For our first problem, we are going to find the area of a rectangle or a parallelogram. And so we're going to start here with number 1. Find the area of each polygon. And so we're starting with a rectangle, and we know we have our formula right here for us to reference. The area is the base times the height. And so we are just going to plug those values in. Here we see that our base is 8 meters. And then our height is 3. And we simply plug it into the formula, 8 times 3. And 8 times 3 equals 24. And so our answer would be 24 meters squared, because it is a two-dimensional shape. And so we want to make sure we include that 2 in our units. Let's look here at number 2, a triangle. So the area of a triangle, we have our formula here, is 1/2 times the base times the height, or you can also think of it as base times height divided by 2, because multiplying by 1/2 is the same as dividing by 2. So we're going to plug in our values. We have the base is 10, so I'm going to plug that in here. B is 10 times the height is 6. So remember, the height is labeled right here, and it's the height of the triangle. So 10 times 6 and then divided by 2. So 10 times 6 would give us 60, and then 60 divided by 2 gives us 30. And it's going to be units squared. So our units for measurement for this problem are feet. So my answer would be 30 feet squared. For number 3, we're going to do the area of a trapezoid. So the formula we have here is area equals base₁ plus base₂ times 1/2, or divided by 2, multiplied by the half. Okay, another formula that you'll commonly see for area of a trapezoid, it's the same thing, 1/2 times b1 plus b2 times the height. Okay, so sometimes you'll see this labeled with b1 and b2. So you're going to add those first. That's the first piece. And then the commutative property of multiplication tells me we can multiply in whatever order we want. So let's start by plugging in these values. Okay, my first base is 6 and my second is 10. So we want to add those first. And 6 plus 10 gives us 16. Okay, so we have 16, and then divided by 2 times the height is 4. So 16 divided by 2 gives us 8, and then 8 times 4 gives us 32. And we're talking about inches squared. So our answer to number 3 is 32 inches squared. Okay, now we are going to find the area of a composite figure. And when we were starting off our lesson, it's just easier to talk about what a composite figure is here, which is basically 2 shapes put together. So we see that we have a triangle and a rectangle could give us this one whole shape. And so that's what composite means. It's just 2 shapes put together for one. And we'll look at what that looks like in a real life situation when we do our word problems. So let's do number 3, find the area of each composite figure. So the 2 different shapes I'm looking at or combining is a square and a triangle, and I am going to use that information for my formulas. So a square is also a parallelogram, so I know my area is going to be base times height, and then my area for a triangle is going to be 1/2 times the base times the height, or base times height divided by 2. So I'm going to plug in these numbers, and I'll just do each at a time. So we're going to do the area of the square first, which is actually super easy. 5 times 5 gives us 25. And then we're going to do the area of our triangle. So we're going to do 1/2 times the base is 5, and then the height is 2. Remember, you can multiply in whatever order you want. So I'm going to do 5 times 2 first. That gives me 10. And then I'll do 1/2 times 10, and half of 10 is 5. Okay, so the area of my triangle is 5, and then the area of my square is 25 inches squared. So I'm going to add them together, and my final answer would be 30 inches squared. So the last step, it's just like what we're doing. We find the area for each shape to start, and then we add those two areas together because composite means we're combining those two shapes as one. So that would be our answer for number 3, 30 inches. All right, for our word problems here, we're going to start with number 1, gardening. So a triangular garden has a base of 10 feet and a height of 6 feet. What is the area of the garden? And so first we're going to identify the shape we're working with, which is a triangle. And I'm going to write down the formula. And if you need to check back in your notes or flip back in your workbook to look that up, go ahead. Area of a triangle is 1/2 of the base times the height. Okay, or base times height divided by 2 is another way we can look at it. And so then I'm simply just going to plug those numbers in. My base is 10, my height is 6, and then I'm going to divide by 2. So and we can multiply in whatever order we want. So if you wanted to do 10 times 1/2 first, okay, 10 times 1/2 or 10 divided by 2 gives me 5, and then I would have 5 times 6 equals 30. Okay, or you could do 10 times 6 first, gives you 60, and then divide by 2, and we still get 30. So our answer is 30 feet squared because we're talking about area. So that's my answer to number 1. So for number 2, we have playtime. A playground is shaped like a rectangle and a triangle combined. So this is going to help tip us off to know that it's a composite figure. It's two shapes put together. The rectangle is 15 meters by 10 meters, and then the triangle is on top of that, and it has a base of 15 meters and a height of 4 meters. So let's draw a picture to help make sense of this problem. So the playground is shaped like a rectangle. Whoops, let's turn it to a pen. Okay, here's my rectangle, and then a triangle combined. So the triangle can be like the top. Okay, and the rectangle has the base of 15 centimeters. Okay, and 10 for its height, and then the triangle has the base of 15 centimeters, and then its height is going to be 4 meters. Sorry, I said centimeters, I think, and I wrote it. So we're actually talking about meters, okay? And so I have my picture drawn and labeled, and then now I'm going to do my formula for each. So for area of a triangle, I'm going to do base times height divided by 2. So our base is 15. Our height is 4, and I'm going to divide by 2. So 15 times 4 is 60, right? 15 times 2 is 30, so 2 groups of 2 is 4. So we have 60 divided by 2, and so the area of my triangle is 30 meters squared. And then I need to find the area here of my rectangle, which is going to be 10 times 15, which is super easy, 150 meters squared. And so now I'm going to add those two measurements here at the end. Remember, composite figure means we're just adding, we're putting those two shapes together. And so my total area is going to be 180 meters squared. My playground, if I was going to lay dirt in it, okay, I would need to know the area of both the triangle and the rectangle to fill the whole thing with dirt. So today we learned how to find the area of different polygons, and it was a real basic lesson where we just simply are looking at what is the formula and then plugging in the values, given values, to find the solution for the area. And so we did some practice problems, we did some word problems, we have a basic idea of what that looks like. Make sure to subscribe so you get those notifications for future lessons, and we will dive into more of, okay, this is how it works. I can just plug in numbers, but why does it work? Where did these formulas come from? Also, our next lesson, if you're following along in your workbook, we will be getting into finding volume, which are three-dimensional shapes. So make sure you're here for that. Thank you for watching, and we'll see you next time.